Hello everyone, I hope you're doing well. In this tutorial, we're going to see how we can analyze different Likert scales using ANOVA, or one-way analysis of variance, on this free open source software, which is JASP. So basically, we have the education level as an independent categorical variable, or we can also call it an ordinal variable. And we need to analyze whether or not there is any statistically significant differences between the different educational groups in terms of the perceptions of AI and the benefits of AI. So to do this analysis, since we have more than two groups, we can run what we call one-way ANOVA, or one-way analysis of variance, which is here. And we are going to go to ANOVA here in the classical function, and we choose it. If we have two repeated measures, like within subject designs in pre-test, post-test, or time 1, time 2, etc., we can run what we call repeated measures ANOVA, etc. Then we have ANCOVA, MANOVA that we can go over, especially when we have experiments or more complex designs. So simply to go for ANOVA, and then I will need to specify the independent variables, or the independent variable, which is in fact the fixed factor as it is named. So simply I will just drag and drop education, and then I would need to go to the intention to use AI, for instance, and then I will simply drop it here, or just click the arrow to move it here. You could see here that there is no statistically significant difference in terms of the education on the one hand and the intention to use AI. And then we need to run the descriptive statistics to see which groups may have higher mean score to use AI. It seems that the PhD group seems to have like a high score to use AI, which is really concerning here. And then followed by the third year. We can, by the way, run even correlation, because these groups here are ranked from first year to PhD. So correlation can also be working to see whether the higher the education level, the higher the positive perceptions of AI. So PhD intend to use peer AI, that's really concerning, followed by graduated, or then we have the second year, etc. It seems that the first year they don't think of the use of AI a lot. So, but here the group size is a concerning factor, because it's just like 7 people, 2 people, 4 people. So you cannot generalize here based on just 2 people, you see. So basically we can ignore these results since they are not even statistically significant. So I will try with another variable till I find something that is statistically significant, and then I can maybe report it in the results. So we have perceived usefulness, or performance expectancy. It seems again that there is no statistically significant difference according to the p-value. So I will remove it. Let me look for AI literacy. Let's see here, AI literacy seems to be almost statistically significant, since the p-value is equal to 0.05 and below. So here we could run other statistics to check that. We can run the estimates of effect size, especially the partial n-square, etc. Then we have the model. Then here we have which model types of model, like type 1, type 2, or type 3. So by default there is type 3. Then we have the assumption checks that can help with the validity of the analysis. In the first hand, we can have the Levene's test of homogeneity of variance, or test for equality of variance, which is Levene's. You could see here there is no statistically significant difference according to the p-value. We can also add the visualizations, the KQ plot of residuals, as you can see concerning the data. We can put the contrast here in case we have complex models with confidence intervals. We can put order restricted hypotheses by including or excluding the intercept, model summary, marginal means, formed hypothesis tests for complex models, like some summary for model 1, marginal means for model 1, especially when it comes to ANCOVA and other complex designs that are used for experiments. So here you have all those functions. We have the post-hoc tests that are also important, and we have so here we can just move this for post-hoc, and we choose which post-hoc we need depending on whether the variance is human or not, like Beams, Howell, Dan, Tukey, Schefe, Benhima, Home, CDAC. So by default Tukey is chosen, but Tukey has some assumption with regard to sample size, etc. I have a table that I can include that will help you decide on what post-hoc test to choose depending on the assumptions, like the equal sample size here in the IV, like the homogeneity of the variance, in addition to other assumptions. Here we can flag significant comparisons. We can also add descriptive plots in case we have, as I said, maybe complex ANOVA, etc. So here you could see the post-hoc comparison, the test that is just Tukey, that is chosen by default, and you could see the pairwise comparison with the p-values that show statistical significance. Here you could see the rain clouds graphics, the marginal means as well, and then we have simple mean effects as well, moderator factor 2. Then we have the non-parametric, which is the Kroskal-Wallis H test. To confirm this, so this is the Kroskal-Wallis H test that also shows that there is no statistically significant difference in contrast to what the parametric one-way ANOVA showed us. So you can see that all the analyses are here, and you can customize this the way you want. You can include different factors. You include different factors, you move from one-way ANOVA to two-way ANOVA, etc., depending on the assumptions and the hypotheses. So this is in brief how we can run one-way analysis of variance and the corresponding non-parametric Kroskal-Wallis H test, and interpret the results using JASP, which is a free and open source software. If you have questions or remarks, do not hesitate to post them below. See you soon, and bye for now.